All right. This is part 2 of today's lesson. My gosh, so this is so involved. We had to do 2 videos for this. All right. In contrast to particles, waves can occupy the same space at the same time. So this is interesting. Waves can coexist. They can occupy the same space at the same time. Particles cannot do that. If you've ever been in a car accident, their energy is completely changed. Would you guys agree their energy is completely changed when they collide as cars? Lots of kinetic energy. When they're done, everything comes to rest. Where did it all go? Probably into heat and sound and things like that. So we've lost a lot of mechanical energy. What happens here is that they sort of, they can coexist. What's the last part? And they can what through each other? What do you think that says?
Intersect.
They can intersect. Thank you. I'm going to use the term they can pass through. These things can pass right through each other. Particles interfere and collide and forever change their motion, whereas waves can coexist and pass through without changing their behavior. Now, I want to talk about 2 different kinds of interference. It used to be that wave interference was talked about in some science classes prior to now, but I'm guessing it hasn't been. Because based on how little we saw with waves before, and this is not to disparage you guys, content's just not being covered the same way that it has in the past. There are different kinds of interference that are going on. Now, this is a crest and that's a trough hitting each other, and when they coexist, right here, I want to draw what this would look like. If this is the red waveform and this is the blue waveform, when they coexist, they would be in the same place at the same time, and when they do, they sort of cancel each other out. Do you know what kind of interference that's called? Okay, that is called destructive interference. So if you've never heard that before, these things are destructively interfering. Destructive interference. And so it should make sense. We're like destructing those waves. Those waves momentarily sort of cease to exist. But then afterwards, they pass through unchanged. And so the red one now has made it to there, and the blue one has passed through, and those things can go on and carry on. Whatever information they contained prior to the intersection, they contain the same information. The same energy that was there. If they were particles, they're done. Waves can pass through. That's called destructive. What would you call this? If this is destructive interference, what would you call that? That's constructive. So now these 2 waves sort of overlap, and they constructively interfere. You can do that as a blue. When they're over top of each other, those 2 things sort of add up, and when they do, they get to that one, and then afterwards we get them passing through. This is called constructive interference. Which kind of interference occurs in your noise-canceling headphones? Raise your hand. You guys know what noise-canceling headphones are? Do you have a pair? Do you know how they work? Simon, explain. Thank you.
They make waves opposite the sound waves outside to disrupt them.
Sound carries its own signature. Noise has its own waveform associated with it. We don't want to listen to that, so what we do is we sample that, invert that through electronics, right? They invert that through electronics, make an exact opposite waveform for the noise, not for your music, but for the noise. Feed it to your speakers, and it cancels the noise, which is crazy, right? How can adding sound decrease sound? By destructively interfering. That's how your noise canceling headphones work. Okay, now when these things coexist, another key thing I want you guys to understand is something called the superposition principle. So you probably have not heard of this before, but you've used it before for a variety of things. Superposition is what happens when 2 things overlap. They coincide. They superimpose. So when waves interfere, the interference pattern is described by something called the superposition principle. It's basically just an arithmetic sum. So I want to write that down as a term for you. Superposition is an arithmetic sum. When these 2 things overlap, the waveform adds or subtracts depending on whether or not they're above or below the equilibrium position. Now, those of you that are computer people, what kind of waves would you call these?
I know.
It's okay if you didn't get. They're called square waves. Computer systems use zeros and ones. Now, this is showing a 1 and a 2, if you will. But computer systems are essentially just ones and zeros that send information as individual bits. 8 bits make a byte and that kind of stuff, right? But when these things overlap, right in that particular spot, if that's 1 and this is 2, what would they add to? 3. The superposition principle is pretty simple when we deal with square waves. When they overlap over top of each other, they would be 3, just for the time being. And then afterwards, they continue on just the way they were before. Can you do this one? This one is a 1. What would you call this one? I'm going to call it a -3. It's below. Would you guys agree it's below the equilibrium position?
Yeah.
So it's below that. Arithmetic sum means I would subtract those values, correct? It'd be -2. And so when these things overlap, we would see something that looks like that. Just for the time being, this is constructive, that is destructive. It's not complete destructive, right? The one that I picked up there was complete destructive interference. This is destructive interference, it makes the amplitude smaller. This is constructive, it makes the amplitude bigger. This is a tricky one. I want to see if you can do it. Notice there are 4 blocks here. 4 of them. 4. That's a space of 4. These are only 2. That's more complicated. Try it. See if you can figure out what that waveform would look like when they coexist. Try it. For those of you that are more visual spatial, meaning that that's a strong suit for you, you're going to find this easier than others, right? Those of you that are a visual spatial kind of person, you look at pictures, you can see patterns, you'll probably find that easier. Once you have it, share with that person that you're sitting next to what you think that diagram or that waveform would look like when they coexist. Should have been a time when I was younger. I can't. All right, you guys are doing that. Sure. I don't know what your partner's saying. How many people feel confident in their waveform drawing for that? You feel confident? Got it. Just a couple? Okay. Duda, you wanna explain? Would you like to come and write on the board?
Sure.
All right. What's your favorite color?
Pink.
All right. This one is pink. What's your second favorite color?
Purple.
Boy, those are really close together. That one's
Blue.
purple. Blue?
No.
Sure not yellow?
No.
All right. When they coexist, come on up and show us what that diagram looks like. Now you got to use your finger for this because I don't have a pen anymore. Put that in.
I don't know if it's red.
It's all right. You're in a safe space here. We're not gonna negatively. You're gonna go with yellow?
Yeah, you
Wait
that
1 second. Wait 1 second. Now you are being recorded here, so if you make a mistake on this, it's gonna be on a recording. It's not Duda. We don't know who this is. Oh my gosh! Here, let's try this again. What color you want? Yellow?
Yeah.
All right. Okay, step to the side.
Wait. Sounds. Oh no, it's fine. It's fine. I thought the line was wrong.
Step to the side. Let people see it.
Can I explain why?
What do you guys think? The other person that said they were confident? That was you back there. Is that what you had? 2 people that felt confident. Oh my gosh, you just went away. Oh, it's there. Okay. Explain, Duda. How did you get this?
So because that is coming that way, so they will sum together, and that was subtracted because of the bottom. So like
you take it off half of that. Like when you divide, you have like that side and that. I don't know.
You're doing a great
You know
job
what
of
I mean?
explaining it. You are.
So like you subtract because they're together and you add. You know what I mean? You got it.
You're doing a great job. This is sort of like a 2 and this is like a -2.
Yeah.
This is like a 1 and a 1, and when those things overlap, 2 and 1 add to 3.
Yeah.
Whereas this is -2 and that's one that adds to -1. Is that what you're trying to do?
Yep.
Give her a round. That's awesome. Thank you, Deidre. There you go. Waveform superposition. I like it. Now, it gets more complicated when we deal with complex waveforms. We're going to save that one for tomorrow. Okay. We're going to save that one for tomorrow. All right. I always forget early release. We go a little bit longer, right? 11:53. It's 11:46. I think I'm going to save that. Yeah, I think I'm going to save that. Okay. Those of you that did not